In this lesson, we are going to work on expanding and condensing logarithms. We're going to be on section 10.6 in your book, and we're going to be on page 848. We will work problem numbers 2 through 16 even and 20 through 28 even. So before we can start, we need to talk about two different properties. So we've talked about before that logarithms are exponents. So when you're working with logarithms, you're actually working with exponents. So here we've got log of b m times n. That's what it means when you've got two variables next to each other. So remember the property when you are multiplying your exponents, or I'm sorry, you're multiplying your bases, you will add your exponents. So we will keep log b the same, and we have our m and our n in the separate logs, and you're adding them together. So down here for the quotient property, when you're dividing this m and n, you are actually going to break it apart to be two logarithms, m minus n, because when you divide, you are also subtracting your exponents. So let's go ahead and look at problem number 2 on page 848. The problem says log 7x. So we will break this apart. We will have 2 log of 3's. One will have a 7. One will have an x. And then since they are being multiplied, we are going to add them together, because the rule is when you multiply, you're going to add those exponents. Okay, so problem number 4, we have log b 2 divided by y. So we're going to write our log b down here twice, and one of them is going to have a 2, and we read from top to bottom, so we're going to write them the way we read from left to right. So the 2 is going to come first, and then the y. So instead of dividing, we're going to use this subtraction here, just like it shows us in that quotient property. So now problem number 6, log 5 y to the 4th. Now this is a property that we haven't gone over yet, but we always talk about when you raise something to a power. So if you had like something in a set of parentheses and then you had like an exponent on the outside, your rule is to multiply that by all the exponents on the inside. So what we're going to do when we are expanding this one, we're actually going to get that 4 and we're going to put it in the front where it's multiplying in front of that log. So our expansion here is going to be 4 log 5, and then we're going to put our y here. Okay. Number 8, log onto the cubed root of z. Okay, so before we can work this problem, I think the easiest way is to change this cube root into an exponent. So if you don't remember this property, I always teach this as you have a base under the radical. I didn't leave myself enough room. The number that goes here is your root, and there is a power known as the exponent above that base. So this is written in radical form. We want to write this actually using that exponential form. Sorry, I got off the paper a little bit. So to write this using an exponent, we're going to write our base, so whatever number is here, and then power over root. Okay, so whatever your exponent is goes on top, and then the root's going to go on the bottom. So when we're using this on this problem here, so my power is 1, my root is 3. So to rewrite this, we would have log z, and then it would be 1 over 3. Power over root. So to actually expand this, we would put that 1 over 3 and we would put it in the front. So that would give us 1 over 3 log z. I apologize about the meowing. My cats are a little jealous of you right now. All right, number 10. Number 10, we have log 7 x3. Oops. Be quiet. Log 7 x3 z squared. Okay, so this one's going to be a little more complex, but definitely something that we can do. So we're going to write our log 7 twice because I've got two things that are multiplying. So my x goes here, and my z goes here. They're being multiplied, so we're going to have that addition in between because of that product property we learned earlier. However, notice we've got this 3 and 2 here. Okay, so this was an x to the third and a z squared. So we have to actually take these exponents and put them in front of their logs. So our actual answer here is going to be 3 log 7x plus 2 log 7z. And that would be your final answer for number 10. Okay. So now let's look at problem number 12. On 12 we have log b x to the third and the cubed root of z. So again, whenever you've got a square root, a cubed root, fourth root, any of those roots, you're going to want to put that as an exponent first. So I'm going to rewrite this as log b x to the 3 z to the 1/3, because remember it's power over root, and that's going to give me log b twice. I've got an x first and then a z. Since they're multiplying up here, when we expand them, they're going to be adding. And then you put these exponents out in front of the logs. So the 3 is going to go in front of your log with the x, and your 1 over 3 is going to go in front of your log with the z. And that's our answer for number 12. So number 14, we have log 5 of 3 over xy. This one's going to be a little tricky. So here we're dividing and we're also multiplying. So we're actually going to write log 5 3 different times, because we need one for the 3, one for the x, and one for the y. So I'm going to write this as log 5. I'm going to put my 3 here. Now, this is division, so remember when you're dividing, you're actually going to subtract. Since both the x and the y are in the denominator, what we're going to have to do is we're going to have to use parentheses, because by doing this subtraction and then the parentheses, that means that all of this that's in the parentheses is going to be in that denominator. So we're going to write log 5 of x plus log 5 of y. And the reason I wrote the plus sign here is because the x and the y are being multiplied. So when you multiply them here, you're going to add them here. So the last thing that we need to do is we need to distribute this negative. So what's going to happen is we're actually going to have log 5 3 and then minus, because a negative times a positive is a negative, so minus log 5x, negative times a positive is a negative, log 5y. And that should be your final answer. All right, 16 is the last one we'll do on this little section. I think 18 is a little more complex than we need to go. So log 4 of x3 y square root of y over z squared. So we can go ahead and put those in parentheses when we write them out because they're both in the numerator. So we're going to get log 4 twice, and we're going to have a plus sign in between those, and then we're going to have minus log 4 of z squared. So here I'm going to have an x to the 3, and then here I'm going to have a square root of y. Sorry, I didn't leave myself enough room there. So we've got a little bit of cleaning up to do. First off, notice that these parentheses aren't doing anything. The reason we needed the parentheses up here is because this subtraction here meant that everything was going to stay in the denominator, and when you removed the parentheses, notice that you had to distribute the negative. Since there is no negative in front that would change the signs, we can actually release that from those parentheses. When we do that, I'm going to take this exponent for x and I'm going to put it out in front of the log. And then notice that I have the square root of y here. This root is understood to be a 2. The exponent is understood to be a 1. So if I wanted to write that in exponential form, it would be y to the 1/2. So I'm going to have a 1/2 go in front of this log. So plus 1/2, that's a 2, plus 1/2 log 4y. Minus, I'm going to put this 2 out in front of the log, so 2 log 4z. Okay, so now on the next set of problems, 20 through 28 even, we are actually going to be condensing these logs. So when we look at problem number 20, we have log 5 of x minus log 5 of y. So when you're subtracting these, remember the operation that goes with subtraction is division. So they're wanting us to write this log 5 one time because the directions say to write it as a single logarithm. And then instead of subtracting these, we're actually going to say x divided by y because subtraction is division in exponents. So number 22, we have 3 log b x plus log bz. So that 3 is going to go as an exponent of x when we rewrite them. So they're also being added. So when we rewrite this as a single log, they're actually going to be multiplied. So I've got log b of x to the 3rd, because that 3 went up here with that x, and then z. All right. Number 24, we have 1/2 log bx minus 3 log bz. So this 1/2 is going to go for the exponent of x, and the 3 is going to go for the exponent of z. And since we're subtracting, we're going to actually be dividing these when we condense it. So we're going to have log b written one time, and I have x to the 1/2 up top, z to the 3 on bottom. But we can still write that 1/2 using a radical. So it's power over root. So it'd be log b. And then your square root sign, your x is still going to be the base. Power is 1, root is 2. So that's like saying the square root of x over z to the 3. Number 26, we have 2 log 5x minus 3 log 5y plus log 5z. Okay, so the 2 is going to go up for the x, 3 is going to go up for the y, and there's nothing that's going up to the z. So I'm going to write my log one time, and x squared is on the top, and then this minus means that we're going to be dividing. Since this is in parentheses, it's telling us that we are going to actually be multiplying all of this under the denominator. So that means that all of this goes in the denominator. So I have y to the 3, so y, and then the 3 goes up here, and then z. Okay. So now moving on to the last problem that we're going to do in this section. Problem number 28, we have log b of x minus 1 over 3 log b of y minus 4 log b of z. So real quick, what I want you guys to notice is that we've got two subtraction signs here. So you might think that we're going to have x divided by y divided by z, but that's not actually what's happening. Notice what we can do is in these last two terms, since this one is subtraction, we can go ahead and factor out that negative. When we do that, we will get a negative on the outside, and then we'll divide each of these by a -1. That's how you're factoring that out. So you get 1 over 3 log b of y plus, because a negative divided by a negative is a positive, 4 log b of z. So now notice that x is going to be up at the top, and then you're going to be dividing all of this. So all this will be in the denominator. Okay. So we have log and then b. So x is in our numerator. 1 over 3 is going to go for our exponent of y. And then 4 is going to go for our exponent of z. But we can still convert this into radical form, that 1 over 3. So I'm going to say, okay, if I've got 1 over 3, then in order to put that in radical form, y is my base, power over root. Power of 1, root of 3. So that's the cubed root of y. Now we're not going to put the cubed root of y in place of right here, because if you've got something that's not under the radical, it should go in front. So our final answer will look like this. So z to the 4 goes in front because it's not under the radical. And then you have your cubed root of y. If you want to put the 1 for the exponent of y, then you're more than welcome to. I hope that you have found this video helpful, and I wish you the best of luck.